Continuing our work with integral tables, we have the integral of the sine of 2 theta divided by the square root of 5 minus the sine of theta d theta. Let's look at our table. Looking again at the types of integrals we have our basic integrals, forms involving the square root of a squared plus u squared, the square root of a squared minus u squared. But what we're looking at here is trigonometric. We have a sine of 2 theta in the numerator and a square root of 5 minus the sine of theta in the denominator. And so I'm going to go to the trigonometric integrals, trigonometric forms I should say. And I notice something when we look at the trigonometric forms. Not one of them involves a square root. So I guess it's not a trigonometric form. Furthermore, inside the square root, we don't have a sine squared of theta. I'm thinking about those forms that involve an a squared, either plus or minus u squared. It's not a problem that 5 is not a perfect square. We can use the square root of 5, no big deal. But there's no square on the sine of theta. So, kind of doing some shopping here, I'm going to go past all of the a squareds and u squareds, and it looks like we might be able to do something with forms involving a plus bu. If we can, then a would be equal to 5, b would be equal to -1, and u would be the sine of theta. That would then imply that du is equal to the cosine of theta d theta. I'm noticing in the numerator that we have a sine of 2 theta. Since this isn't a trigonometric form, we're not going to be able to come up with a sine of 2 theta by using a table. So I'm going to rewrite the original integral and express the numerator as 2 times the sine of theta times the cosine of theta. And then the denominator is, of course, the square root of 5 minus the sine of theta d theta. And now what I have in the numerator is, if u is the sine of theta, then the numerator is 2u du if we include cosine of theta with d theta. Furthermore, we do have that square root in the denominator, and so I know that the first chunk of these forms on the right aren't going to work. None of them have square roots. So I'm showing you a good number of these. What I'd like for you to do is pause the video for a few seconds and see if you can identify what form this matches up to. I hope you are able to identify the integral of u du divided by the square root of a plus bu. In this case, what we have is u is equal to the sine of theta, and du is equal to the cosine of theta d theta. Knowing then that a equals 5 and b equals -1, and we're using the form integral of u du divided by the square root of a plus bu, what I'd like for you to do is flesh out what that form becomes on the right-hand side and give your answer in terms of theta. Pause the video and work on that, please. I have the form boxed on the right, and we're looking at 2 over 3b squared times the quantity of bu minus 2a times the square root of a plus bu plus c. So fleshing that out, this integral will equal 2 over 3, because b squared is 1, times negative sine of theta, because that's bu, minus 2a is -10, times the square root of 5 minus the sine of theta plus c. But I realized something. I missed in front of the whole thing that factor of 2 from when we used the double angle formula for the sine function. This can be simplified by multiplying the 2 by the 2/3, and then I'm going to go ahead and pull the negative out of the binomial that we have, or the two-term expression. So we have -4/3 times the sine of theta plus 10, that times the square root of 5 minus the sine of theta plus c.